So today is lesson 4.4, and we're going to be solving equations that are in this form. So ax plus b equals cx plus d. And if you notice, there's an x on both sides. So we're basically going to be looking at equations where now there's a variable on both sides. So not just having to simplify, but deal with how do I clear out an x or a y on either side of the equation. So something we've covered before in middle school and some pre-algebra, math 7, math 8. And we're going to kind of take it to another level today. So our big idea, an equation in the form ax plus b equals cx plus d can be solved with just one more step than solving the ones we've been looking at, the ax plus b equals c. So there's just one extra step. And that step is to clear out one of the variables that's on both sides. Once we do that, it goes back to the form that we're used to. Okay, so example number 1, I've got a 5x on the left and I got a 9x on the right. Now technically I can start dealing with the minus 12 and the 16 if I want to. Best practice, though, is to clear out your smallest variable first. Now, this is a best practice. This isn't something you have to do. So out of these two, the 5x is smaller than the 9x. So the best practice is to clear out the 5x. Now, how do you get rid of it? I want to subtract it to get it to 0. And that's still going to leave me a negative 12. So if I subtract 5x, we know that we can't just randomly subtract something over here. We have to do it to both sides of the equation. If we have 12 equals 12, I can't just minus 2 on this side and get 10 and say that it's equal to 12. I need to minus 2 on this side. And now both sides are still equal. So as long as I subtract 5x on both sides of my equation, it's still going to hold true. So I want to get this to 0, so I'm going to subtract 5x. If it was a negative 5x, I'd actually have to add 5x to get it to 0. So they're going to cancel out. Bring this subtraction down as a negative. 16 comes down, and 9 minus 5 is a 4x. So here's why we subtract the smallest one, or clear out the smallest one. It's because it leaves us with a positive coefficient for our variable. If we had done the other way around and subtracted the 9x, we would still get the answer right if we followed our steps correctly. But if we minus 9x on both sides, we'd end up with a negative 4x over here. So we're creating negative numbers for no reason. Now, as long as you deal with the negative numbers correctly, you're still going to get the answer right. So you don't have to clear out your smallest variable first, but it is your best practice to stay away from the negatives. And especially tomorrow when we start looking at inequalities, dividing by a negative is when things get crazy, when you have a less than or a greater than. So let's just avoid them altogether in the first place. So we're going to clear out the smallest variable first. And now we have an equation that's in the form ax plus b equals c. Just a little two-step equation. And we all should be good at these from here. So we're going to minus 16. Remember, our goal is always to clear out all the numbers so that x is by itself. So now I'm trying to move everything this direction, get it out of here, so that x is left all alone. So now that I've cleared the 16, I just have a 4x. Subtract these, that's negative 28. And now I can just divide by 4, and I have finally gotten x by itself. And so my answer is x equals negative 7. So let's check it. It did say solve and check. You must go back to the original. So all the way back to 5x minus 12 equals 16 plus 9x. And we're plugging our answer in everywhere we see an x. So here and here. 5 times negative 7. And 9 times negative 7. All right, so when we multiply here, that's negative 35. And we multiply over here, that's negative 63. Combining, we get negative 47. And 16 plus a negative 63, or minus 63, is also negative 47. And so we're good right there. So really, this is all about just step 1. Clear out your smallest variable first. And at that point, it's just a regular equation like we've been working with. So if we slide down, this next one looks like a pretty small equation. But I do still have a variable on both sides of my equal sign, and I don't want that. I just want one variable. So out of these two, what's my smaller variable? A 9 and a negative 6. Negative 6 is smaller. Now to get that to a 0, I have to add. So think about it like an opposite. It's a negative. I need a positive 6 so that they cancel. So I'm adding 6n to both sides. So that's going to give me 15n equals 5. Now be careful. A lot of people here will automatically, they'll start dividing and they'll just say 3 because they say 15 and 5. What are we dividing by? The number that we want to clear out. We're dividing by 15 because we want it to clear. Now n is by itself. 5 divided by 15 is not 3. Okay, it's 0.3 repeated. You can simplify, divide these both by 5. It's 1/3. 5 divided by 15. 0.3 repeated, which is 1/3. So our answer here is 1/3. Let's go to our check. So it's 9 times 1/3. Now 1/3 is just like dividing by 3. So 9 divided by 3, that's easy. So no stress there, even though it's a fraction. And same thing with that -6. So first of all, right here, 9 times 1/3, you can times by the top and divide by the bottom. That's just 3. 9 divided by 3. And over here, same thing. Times by the top, divide by the bottom. So it's -6 divided by 3. That's -2. And so 3 equals 3, and we're good. If you went back and if you thought your answer was 3 and you plugged it in, you would have got 27 on this side, and then you would not have gotten 27 on this side. So that would have told you, okay, something's wrong. Go back and find it. So 5 divided by 15, 0.3 repeated, that's 1/3, or just simplify the fraction 5 over 15. All right, last one like this. So now I have variable on both sides, a -8 and a +1. -8 is smaller, so I'm going to add 8p. Now it's negative, so I added it to get it to 0, leaving me just 46. And over here, that's a 9p. All right, get that p by itself, so I'm going to minus 19. So 46 minus 19, we're going to get 27 equals 9p. Divide by 9. And p equals 3. Now instead of doing a check on this one, I want to show you that we could do this differently. So I'm going to go back to the original here. So what if you chose the p? What if you looked and you saw, well, that's an 8 and that's a 1. I'm going to get rid of the 1, even though it's a -8. But let's say you made that error. It's not really an error because you can get rid of either side. So let's minus p first. Since it's a positive, I'm going to have to minus to clear it. So what happens? This goes away. I still have 19. I still have 46. But this is a -8 minus 1. That's a -9p. I can still get it right from here. I want to get p by itself. I'm going to clear out the 46. It's positive. I'm going to subtract it. Remember, this goes with the 9. So a positive 46. To get it to 0, I'm going to subtract it. Bring this down as a -9p. It's -27. Divide by -9. Negative and a negative. Same answer, +3. So you don't have to go after the smaller of the two coefficients, but we ended up with a bunch of negatives here. And where do we tend to make careless errors when we have a bunch of negatives? So my suggestion is always go with the smaller of the two variables, clear it out, and create positive coefficients, and you're just less likely to make a silly mistake along the way. All right, if we flip it over, what happens when we have a whole bunch of stuff going on both sides? Well, you want to simplify first. So we're going to simplify both sides first. So starting with the left side, this is like a -1. I need to distribute it in. And on this side, I got a 4, and I need to distribute it in. So the 7 stays. -1 times x is -x, so minus x. And then the biggest mistake people will make is write +5. The minus comes here as well, so it's a -5. This side, 4x plus 44. I would still finish simplifying the left side before I do anything here. Now, there's tons of different ways. There's different steps to solving an equation. You could start moving stuff now, and you'd still get it right if you followed all your steps correctly. But I do suggest you simplify both sides completely before you start worrying about where my x's are and stuff like that. So I have a 7 and I have a minus 5. So I can put that together, and that's 2. And I still have a minus x. So what did I do? I put the 7 and the minus 5 together. Okay, and now I'm looking at this. All right, the left side's simplified. The right side is simplified. Now I can start clearing stuff out. So if you look, this is a negative 1x and this is a positive 4x. One of them's got to go. I would get rid of the negative. So let's add a 1x to get it to 0. So that just leaves me 2. I get a 5x on this side, and I still have a 44. And now it's very simple two-step equation. Ax plus b equals c. So minus 44. That's negative 42. 5x dividing by 5. And don't automatically go, well, that's not going to divide by 5. I must have done something wrong. Okay, not every answer is going to be perfect. So if we take negative 42 and divide it by 5, we actually get a pretty nice decimal. So we don't need to leave this as a fraction. We can go straight to the decimal. So my answer here, x equals negative 8.4. All right, let's try the check. We got a lot to deal with here, right? And it's a negative decimal, so let's not let that scare us. Back to the original. If you want to start plugging in on your first step, honestly, I'm okay with that. But I want to work directly underneath so it's clear what I'm doing here. So everywhere I see an x, I'm going to change it to a negative 8.4. So 2 spots to do that in, right here and right here. And now you need to follow your order of operations. You don't need to distribute. Distributing will work, but that's more for when you have a variable in there. We really can just follow order of operations. So you're going to be adding inside of parentheses first. So negative 8.4 plus 5 is negative 3.4. So it's going to be 7 minus that, so really plus. So if I was adding here, 7 plus 3 is 10, so this is 10.4. All right, and then on the other side, the negative 8.4 plus 11 is going to give me 2.6. And so it's going to be 4 times 2.6. And at first glance, you may look at that and say, well, that's not going to be right. But go ahead and do 4 times 2.6 in your calculator, and sure enough, it's 10.4. And this all worked out. All right, so now let's take this one step further, because really we covered all of this in middle school to a certain degree. So now let's start applying this to some actual word problems and making you think a little bit. So as we slide down to example number 3, we're going to have to write the equation, and it's going to look similar to this. We're going to have an equals, x on both sides, and we're going to have to solve it. So Jamie's got $25 in her bank account and just started depositing $20 per week. You may want to start writing that out automatically. Okay, so we've been translating these into expressions. Let's just go ahead and do that. So she's got $25, and then she's going to deposit or add $20 every week. So plus 20W. Now Mark, he's got $100. I'm going to keep him over here. I don't know what I'm doing with them yet. $100, and he's going to deposit $15 a week. So it says, how many weeks will it take until they have the same amount of money in their accounts? So this one's going to tell me how much money Jamie's got in her account, and this is going to tell me how much Mark has in his account. I want to know when they have the same. Same means equal. When are they going to have an equal amount? So I'm going to take both expressions, and I want to know when is her account the same as his account. When are they equal? I'm going to rewrite this real quick just so it's all close together. So if I want to know when they have the same amount of money, I'm just going to set them up as equals and solve it. So now I've got a variable on both sides. The smaller of the two is the 15, so I'm going to start there and clear it out. So that leaves me 100. 20 minus 15 is 5W, and I still have the 25. And now it's a basic two-step equation. Get that W by itself. So I'm going to minus 25. And 5W equals 75. Divide by 5. 75 divided by 5 is 15. So to answer the question, if W equals 15, what does that mean? That's 15 weeks. Okay, and you may want to go back and double check it and say, okay, well, if it's $20 per week, 20 times 15, that's 300. And then if I add the 25 that she started with, okay, she's got 325. So I'm just double checking and making sure that they really do have the same amount in their accounts here. So he started with 100 and it's $15 per week. So if it's 15 weeks and it's $15 every week, 15 times 15, that's 225 plus the 100 that he started with. And sure enough, I got 325. So you can run a quick check. You don't have to show a formal check written out, but go back and make sure. If it is 15 weeks, make sure that Jamie's account and his account actually do come out the same. And if they don't, then that means you just messed up in your algebra somewhere and you can go back and you can fix it.